Next, what other details can we add? If we look up some information about cars, we'll find the steering angle of the wheels isn't actually the same on the left and right. There's a certain difference between them. When we steer, for example, turning this way, the inner wheel actually turns at a larger angle, and the outer wheel turns at a smaller angle. There's a corresponding mathematical study on this called Ackermann's steering geometry. We can look it up if we're interested. We can even take the corresponding mathematical formulas and connect them using utility nodes in Maya. This way, when steering, the rotation angle of the two wheels will be very precise. We don't need to be that precise here. We can just use some simple utility nodes to connect a general effect. Let's first briefly analyze what effect we need for wheel steering. First, as mentioned, when rotating to one side, the rotation angle of the inner wheel must be greater than the outer wheel, and these three angles are actually a comparison. This is our car body's rotation angle. The inner wheel's rotation angle should actually be slightly larger than this angle, and the outer wheel should be slightly smaller than this angle. This relationship isn't completely fixed either. What does that mean? It means as the car body's rotation angle gets larger, the difference between the two wheels and the car body's rotation angles will also get larger. This one will get progressively higher than the base value. This one will get slightly lower than the original value. I've exaggerated this a bit, but we can get the idea. For example, if we're at 30 degrees now, it might be a result like this. The inner wheel might be, say, 1.2 times the actual rotation angle. And this side is, say, a 0.85 multiplier. But when we are closer to the center, these two wheels compared to the actual rotation angle won't differ by that much. It's closer to a one-to-one effect. We have some understanding of the behavior now. Next, let's see how to implement it in Maya. First, we need to see which node is driving the steering. Let's find the two connect groups for the wheels. Open the node editor. Show their inputs. Here we see the plus-minus average node. We know this node holds the steering angle control from all the controllers. So let's remove these other unneeded nodes from the node editor. We know this plus-minus average node's result is the final steering result. And then we're controlling the left and right wheels. We need to discuss two situations here. One situation is rotating to the left. Rotate Y is a positive value. At this time, the left wheel's rotation angle will be larger. The right wheel's rotation angle will be smaller. The other way is to the right. This is a negative value. Then it will be the opposite. The right side's angle will be larger. The left side's angle will be smaller. Let's zero it out. Since we're talking about discussing different situations, there's one node very suited for this. It's the condition node. Let's create a condition node. Then take the final value from the plus-minus average node and connect it to the first term. Then we'll compare this value with the second term. Let's set the second term to 0. Then we'll use greater or equal. This way, when it's greater than or equal to 0, we know the car is turning left. When it's less than 0, it's turning right. This corresponds to the rotation effect of each wheel. When it turns to the left, which is color if true, what angle should the left wheel rotate? What angle should the right wheel rotate? If it's a negative value, then it's turning to the right. What angle should the left wheel rotate? What angle should the right wheel rotate? Finally, take this result and connect it to the connect groups of the two-wheel controllers. What other node do we need here? We mentioned earlier, as this angle gets larger, the multiplication factor will keep increasing. So we need a remap value node. Because we know the remap value node has this kind of changing trend, it can remap the values. Let's start with the left side. Let's call it turning weights in, because this is the inner side, meaning it's the weight when turning to the left. Let's connect the steering result from the plus-minus average as its input. Then we need to set a limit. A car's maximum rotation angle is generally in the rough range of 30 to 45 degrees. Let's use 30 degrees here. If we need a very precise value, we might need to look up the car model's documentation to see its corresponding maximum angle and set it. Okay, we know 30 degrees is the angle for turning left. This is the left wheel, so the multiplication factor will be larger. Let's set it to 1.2. And the minimum value will be consistent with the car body's rotation. Then let's duplicate 1 for the outer side. This will be negative 30. We know it will be less than the base rotation angle. Let's set it to 0.85. Then we need to take this weight value and multiply it by the car body's rotation angle to get this wheel's different rotation angles in both directions. So let's create a multiply divide node. Why are we using a multiply divide node and not a mult double linear node? This is really my personal preference because I have two nodes here that need multiplication. If I use mult double linear, I'd need to create two of them and then connect them. But the multiply divide node has 3 input attributes. I find it looks a bit cleaner. This is completely a personal preference. We could absolutely use mult double linear nodes, so let's rename it. Then connect the car body's rotation angle to input 1x and input 1y, because we need 2 attribute slots. Then connect the remap value node's value to input 2x and input 2y. Make sure we're connecting the out value. This way, next, we connect the multiplication result to the condition node. We know when the body rotation is greater than 0, it's turning left. That means the left wheel is the inner wheel. So here we connect output x to color if true R, and output y to color if false R. This way, look, when we turn to the left, it will take this value of 30.49. It will be slightly larger than the car body's rotation of 25 degrees. And when we rotate in the other direction, it will take this negative 19.815 value. It will be slightly smaller than the base negative 22 degrees. Let's connect this result to the connect group. Its out color R connected to rotate Y. This way, let's take a look. There will be a slight difference, not too obvious. Let's apply the same effect to the right side. Let's duplicate 1. The values for the right side need to change, because it's the rotation effect for the other side. So the limit should be negative 30, and the outer side for the right wheel. The limit here becomes positive 30. It's the complete opposite of the left. Then create a multiply divide node as well. And connect the remap value over. And connect it to the condition node. Now we need to check here. The color if true situation is turning left. When turning left for the right wheel, that is an outer side rotation. So be careful here. Our outer rotation is connected to the multiply divide node's input to Y. So here we need to connect output Y to color if true G. And conversely, output X to color if false G. This way, let's connect this final result to the right side. Then let's look at the result. We've rotated a certain angle, about 25 degrees. Let's see. The right wheel is about 22 degrees. The left wheel is about 30 degrees. If we rotate to the other side, the left wheel is about negative 20 degrees. The right wheel is negative 26 degrees. And our actual rotation angle is now negative 22 something degrees. This way, we've achieved the result we wanted. Then let's clear the node editor. Close the node editor. This way, the wheel steering angle setup is complete.